Hello, in this video I'm going to share a few more examples of using the Po-Shen method to find solutions to quadratic equations. Okay, this would be example 3. If you didn't see the previous examples, the video will be linked at the end. So the first one here we're going to be working on in this video is y equals x squared plus 4x minus 21. First step is to identify the b value and to negate it. So the negative b in this case is minus 4. Second step is to identify the product that you'll be looking for. And the product is your constant term, or your c. In this case, it's negative 21. Once you've found those two key pieces, you are going to make a statement. So negative b divided by 2 is negative 4 divided by 2. That's negative 2. So this value of negative 2 represents the location of the line of symmetry, the x value of the line of symmetry. On your quadratic, all quadratics have this feature of symmetry, and that's one of the nice things about this method is that you have to pass through that to get to the rest. So if I was sketching the graph, I would already know that x equals minus 2 is where the line of symmetry is. Okay, so next step. Negative 2 and some amount to the left is one of the zeros, or one of the solutions, and negative 2 plus some unknown value is the location of the other zero, or the other solution. Now I'm going to do the product of each of these. So negative 2 minus u times negative 2 plus u equals that negative 21 we picked straight out of the equation to start with. This multiplication, binomial times binomial, is going to result in a difference of squares. So negative 2 times negative 2 is 4, and then the plus minus u will generate negative u squared. Isolate for u. First we're going to bring it over to the right hand side, so it's by itself, and that's 25. If u squared is 25, then the value of u is plus or minus 5. At this point, now that I have a value for u, I actually have two values, I can put it back into these statements. And it doesn't matter whether you take the subtraction statement or the addition statement, it will work out the same. So the zeros for this quadratic are going to be negative 2, leaves the addition, plus 5, and there's another one at negative 2 minus 5. So that's 3 and negative 7. So if I was being asked to write the factored form of this quadratic, it will be x minus 3 times x plus 7. And you could test it out using distribution. You could do FOIL, if you've learned it that way, to verify that these two factors do indeed produce that original trinomial. Okay, let's look at another one. X squared plus 9x plus 14 14. So first step, identify that b value and negate it. So it's -9. We're going to divide that by 2 as the next step. So that's -4.5. So already I know that my zeros are going to be located at -4.5 minus u and -4.5 plus u. So some distance to the left and some distance to the right of that line of symmetry at x equals -4.5. The product that we're going to be looking for comes from that constant term 14, positive 14. If you want to put a little positive in there, that's good too. Okay, so the product, -4.5 minus u times -4.5 plus u is 14. Again, that's going to generate a difference of squares. So 4.5 times 4.5 is 20.25. And the plus and minus u are going to generate a term of minus u squared. Isolate for the u squared. That's going to be 6.25 on the left. And that means when you square root that, square root of 6.25 is going to make plus or minus 2.5. So at this point again, you bring that value of u back into your original statements for the zeros. So -4.5 plus 2.5 is one of them, and -4.5 minus 2.5 is the other one. So this one is -2, and this one is -7, are the zeros of that. Factored form of this quadratic is going to be x plus 2, x plus 7. And you could verify that answer by distributing and using first outside, inside, last, if that's how you've learned it. Multiply each of the terms by the other two, and you should be able to find that it does generate that original trinomial. So that was showing you that it is possible for the u value to be a decimal. It's possible for the -b to be an odd number. That's fine. It doesn't change the efficacy of this process, this particular method. Okay, let's look at another one. X squared minus x minus 6. -b, in this case the coefficient is a 1, so -b is going to be positive 1. -b over 2 is 1 over 2, 0.5. And rather than putting in a fractional value there, I am going to use a decimal. The product that we're interested in is that constant term, so it's -6, it includes the sign. X equals 0.5 would be the axis of symmetry for this particular parabola if I were graphing it. Okay, so the zeros are going to be located at 0.5 minus u, and 0.5 plus u. So some value to the left and the same distance to the right of the axis of symmetry will put you at the zeros. Product is negative 6. This is 0.25 minus u squared is negative 6. Isolate for u squared. And this is going to be 6.25. So the u value here is plus or minus 2.5. From there, I can say that the zeros are 0.5 plus 2.5 and 0.5 minus 2.5. So that's 3 and negative 2. So if I were being asked to find the factored form of that quadratic, it's x minus 3, x plus 2. And it's always a good idea when you do find the factored form to double check, do a verification, multiply it out quickly to see that it would result in that original trinomial.